So, sustainability and the environment. Now, what you have to understand is in this section, new and emerging technologies, you're just needing a general sort of overview knowledge of these areas. It's the specialist technical principles where you need to be able to know a bit more depth about them. So that's why these screencasts are going to be a little bit briefer than the ones that in specialist tech. So when we're talking about sustainability environment, the first thing really we can think about is finite resources and non-finite resources. Now, when we're talking about this, we are talking about, first of all, energy. So finite resources, this means like coal, oil, and natural gas. I should say crude oil, actually. So fossil fuels, the things that are finite resources. On top of that, for energy, we then have uranium, which is used for nuclear power plants. Now, uranium is the lifetime of uranium in terms of how long, like, say, one uranium rod can be used for is a lot longer than, say, a lump of coal can be burned for. But yeah, um, it still has highly hazardous and polluting on the earth. Now, what's annoying with these energy sources is not only are they finite, so they will run out, but also they pollute as well. So it's when you think of it like that, it's ridiculous. It's like we are mining and harvesting and pumping all as much of these materials as we possibly can, and then at the same time, it also causes a huge amount of pollution as well in the world as they're burned. So all in all, it's a bit of a lose-lose scenario, and they're not even that energy efficient either. Yeah, it's crazy, really. So, from a UK perspective, coal is the main fossil fuel used for generating electricity. So there's a lot of coal power stations around the UK. Now, what's interesting to Google is looking at countries that use, or countries around the world, and the methods of energy that they generate. So, seeing which countries use more nuclear power than fossil fuels, and which ones use the most renewable energy. It's very interesting to see the comparisons around the world on which countries are sort of the most proactive. Now, we live in strange and uncertain times. Finite resources are running out very quickly. Certainly in your lifetime, they'll run out. And it's old hat technology. It's technology that humans, society have relied on for far too long. And this is something that's going to come up and it's going to give us a massive kick. Because, yeah, I mean, gradually we're shifting over to non-finite resources. But the trouble is, like, trying to shift governments and large, huge corporations to shift their consumption to renewables is effective and very difficult. So that it really takes big action from the very high up powers. So finite resources also applies to materials. So things like um, plastics are refined generally from crude oil, and because crude oil is finite, plastics also essentially will, they are finite resources. Um, Equally, metals come from ores, which are mined from the ground. Those are finite resources. Battery materials. This is a huge one at the moment. Battery materials are refined. Sorry, lithium and nickel are materials used a lot in batteries. In fact, they're the sort of the fundamentals in rechargeables used now. And the trouble is those are running out. And so now with the development of EVs and electrifying everything, it's all great. But the problem is that the battery supply chain, the materials for the battery supply chain is completely broken. So that's something that will have to be fixed and sorted out in order for countries or the world to mass migrate to, say, purely electric and using renewables. So getting on to non-finite resources, this is looking at how can we generate energy how can we generate energy from resources that will never run out? So we're talking about the Earth's elements here. So we're talking about how can you harness wind power, how can we harness solar power, tidal power, geothermal power, like all these different methods we have of generating energy, harvesting energy. Is some of them are really powerful. Like when you look at an infographic of the potential number of kilowatt hours from different energy sources, solar is by far the biggest, like in terms of its potential, the potential energy that we can harvest from the sun. solar has the most potential kilowatt hours out of all of them by a long way. Yeah, it's a very interesting infographic to Google that, is to see what the difference is. So yeah, and that applies to materials as well, like timbers. If they're harvested and in deforestation is conducted in a sustainable manner, timbers are non-finite resources. Like we can grow forests back. That's it's not easy, but it's something that can be done if it's managed properly. And by default, papers and boards are products of timbers. So, yeah, those materials are more sustainable because they are renewable and replenishable. And things like bioplastics now are becoming more and more prevalent, particularly for packaging for food. So things that are made from like cornstarch or potato starch, what we call cornstarch polymers, so things like PLA, which you use on 3D printers now. Like you get a lot more like plant-based polymers that are being created, and that's good because they are essentially they're more likely to be non-finite, and plus they're biodegradable as well. So yeah, so then that leads on to biodegradability and resource recovery. So biodegradability, the actual definition of this is a material that can break down naturally in landfill within a human lifetime without polluting the ground or without polluting the atmosphere. So a good example of this would be pretty much any timbers or organic waste, we call it, because say if you have like a purely like wood pulp carton that's been used for a bit of packaging or something, if you were to just throw that in the bin, that goes to landfill, that would biodegrade pretty quickly. Like it wouldn't even be a lifetime. It would be a lot less than that. Things same with papers and boards and things. As long as there's no like other things put onto them, like the trouble with boards particularly is you get a lot of boards which have like a layer of plastic laminated onto the top because it protects the surface or it makes it water resistant or it makes a better printing surface for ink to go onto. So this is the problem with things like Tetra Pak that you get for a lot of like cartons for milk and fruit juices and things, is that they're made from papers and boards, but they are coated in aluminium foil on the inside, and on the outside they've got plastic, and then they've got a little plastic spout, so they're really not environmentally friendly at all. So yes, plastics are a huge problem because these take like over 100 years to biodegrade, and plus that process, things like microplastics being released into the ground and chemicals being released into the ground, those chemicals can never be absorbed and sort of reprocessed by the environment. They just stay as they are. So they are like a permanent pollutant in the ground. So the more things like that are just thrown away, the more damage it does. And even worse things are like sort of the more hazardous metals that we get, like lithium, that's used for batteries. Like that's why we should not throw batteries, or lead acid batteries, even worse. We should not throw a lead acid battery, or any batteries should not be thrown into landfill because they are a massive pollutant to the environment. So then getting on to resource recovery, if you click on this hyperlink here, it just jumps to this interesting company called Redwood Materials. Now, this is a guy started by a guy who used to work with Elon Musk at Tesla, and he basically just branched off and he started this company that's really in a big way like looking at how can we recycle everything. Like you see here like a big one that they're looking at the moment is lithium from batteries. Like how can they recycle lithium from batteries and nickel to then be able to then reprocess those back into batteries again, so that we're trying to create what we call a closed loop economy. So it's an economy that can that can go round and round and round. So you're never using raw material. You're actually just reclaiming material that's been used already, and then you're recycling that to then be used again. So that's what we call with sort of material recovery. Then we can do the same with energy. Like say with energy, energy recovery could be if you have a process that generates a huge amount of heat, for example. Is that heat just going to waste? And if so, could that heat be harnessed to do something else? So say if you've got a huge like electrical generator up in a very cold country, and the generation process creates a lot of heat as a byproduct, could that heat be siphoned off to create hot water that can then be pumped out to different houses and stuff? So that's how we can sort of look at recovering energy as well. Now, global warming, this is something that hopefully you all will be familiar with, but it's basically the effect of the more greenhouse gases that are created. It unfortunately has the effect of trapping ultraviolet rays from the sun in the Earth's atmosphere, and the result of that, and trapping the heat from the sun, and gradually the effect of that is it gradually warms up the Earth's the Earth's average temperature. Some people deny that it happens. Personally, I think they're stupid if that's what they believe, but everyone's entitled to their own opinion. So I think the argument is that global warming would happen anyway, but the point is that we're currently accelerating it way faster than it would be happening naturally. So planned obsolescence. This is where companies if a product goes obsolete, what this means is that it goes out of date and it's no longer relevant. So, for example, a horse and cart as a method of transportation in Hong Kong is obsolete. A rickshaw in Hong Kong is obsolete. A sedan chair in Hong Kong. I mean, we're talking very culturally specific examples here, but those are obsolete. Technologically and socially, they are obsolete now. But the reason for that has happened through various range of things. Number one, social pressures. It would deem that those are sort of they are like not good forms of transport at all, because it requires a huge amount of human slave labor, or just not slave labor, just very, very hard, badly paid labor for people to transport those things around. Plus, it's hard work in a hot environment. So technologically, those have become obsolete, and socially they've become obsolete because new technologies emerge, like petrol cars come along, and suddenly that makes when Henry Ford started the mass production of the Ford Model T, that suddenly made horses and carts redundant, because companies were like, oh, we can just buy a car, not even that expensively, and suddenly we've got way faster transportation. Now companies are very naughty because they deliberately design products that go out of date, because then that way they make sure that people keep buying the newest version. So there is no reason why an iPhone can't last a lot longer than it actually does. So one of Apple's ways of making sure that people buy new iPhones is, and in fact all phone manufacturers do this, is they make the operating system run slower on the older models. So say if you have an iPhone 12 now, the chances are that the latest iOS version will run quite a lot slower, almost painfully slow on that older device. Now they'll argue that it's because with the processing power required from as the internet gets richer and more content is added, we need devices that can process this data faster. But you think like, yeah, sure, but that there is genuinely in there, like there's some that you need to think of it like this. They're not just interested in selling products, they're interested in actually making sure you're locked into buying products from them. So other companies that have been had up for this before, like companies like Canon and HP that make printers, they actually make more money off the sale of ink cartridges than they do actually off the printer sales, which is ridiculous. And that's because they design it so that the ink cartridges will run out very quickly, or that the printers will break after a certain. I say they will break after a certain number of prints, and lo and behold, it's going to cost this amount to replace that part. It'll only cost a little bit more just to buy a new one. Do you want to just buy a new one? So us as consumers, and especially as designer consumers, we really need to be aware of the wool that is pulled over our eyes through this. Like, it's just bizarre. Like, an iPhone is deemed to last 2 years before people will sort of think, it's probably time to get a new one. An iPad, for some reason, is deemed to last a lot longer than that. A MacBook is deemed to run a lot longer than that, when actually there's not really any difference between them in terms of the actual hardware and what they process, particularly between the iPad and the iPhone and the iPhone. So we have to be really wary of this. Now, it's not always been the case. Products have not always been designed to go out of date this quickly. It's just because companies realize they can make a lot more money by making sure that they make their products go out of date after a certain length of time. That way they guarantee a revenue stream year in, year out. The worst business model is designing a product that's so perfect that it never needs servicing, it never needs changing, it never needs updating. That's like, the company might as well just like release one product and then close. That's the issue with it. So yeah. Now, continuous improvement. This builds upon planned obsolescence. So continuous improvement is also, it's the positive side of planned obsolescence. If companies don't continuously look to improve, there would be no development in the world. We would still be driving cars that look like this. In fact, no, we wouldn't be driving cars at all. We'd still be riding horses. Yeah, we'd still be riding horses around. We need to have a policy and have a mentality of continuous improvement. So we're always looking at how things can be done better, more efficiently, using less energy, using less material, how it can be done cheaper, how it can operate better. It's down to designers and manufacturers to always be aware of this and to always think about like better ways of doing things and more efficient ways of doing things. Even from point of view in school, like you guys are continuously improving the way that you learn. Like without even thinking about it, you will be, because even the way you study, you'll start to find new ways of studying that work better for you, whether it's different ways of making notes or quicker ways of making notes or ways of condensing things. That's continuous improvement the whole time now, and that's hopefully applied to all walks of life. Like we are constantly looking to improve our health, our physique. We are constantly looking to improve our wealth. Like these are all things that we're always trying to do as a human population, and that comes from identifying all sorts of little minor tweaks. And that's why people get so obsessed with diets and things, is because those are all tiny little continuous improvement tweaks we can do to our lives in all sorts of different ways to sort of micromanage every area, which will lead to a big grand continuous improvement or step forward in our progression. You guys will go from school, hopefully to university. That is a continuous improvement in your education. And from that, you'll then graduate, and then you'll get a job, and then your knowledge is constantly building the whole time. So we have that for ourselves, but we also hopefully have that mentality for companies as well with the development of things. And ideally, responsible companies, it will mean that we actually move towards a more sustainable future, where there's less pollutants are used and less energy is used to make stuff, and that's the ideal situation. Okay, that's it from this section. So well done for persevering.